friends, welcome back. So in the previous videos, we've been talking about different machine learning algorithms when we implemented some of them in Python from scratch. And today we are back with another video. So in the previous videos, we talked about the k-nearest neighbor algorithm. We did discuss the linear regression, the naive Bayes, and the k-means algorithm, right? But in today's video, we want to be focusing on the decision trees. We want to talk about what are the decision trees, how they work, and eventually we want to implement a decision tree from scratch in Python. Okay, so let's get started. What is a decision tree? A decision tree is basically just a tree like a structure. And when I talk about a tree, so it means that, let me go here, activate my pen. So it means that I have a node up here, a node, a leaf, whatever you want to call that, right? And I want to make a decision. So there is a condition here, right? And I want to make a decision based on that condition. If that condition is true, I go here. And this is like an agreement. If it's true, then you go to the left side. If it's false, you go to the right side, right? So if that condition is true, I'm going here and then another node in here. And if it's false, another node, right? And then like there could be another condition in here. So here it could be like a second condition, for example. And then like if it was true, go here. If it was false, go there. And then this could not be a condition. It's just like, that's it, like the end of it, right? What makes like this tree grow is like you can keep going basically as long as you have pure nodes, right? This is what we call them. Let's say like you have let's say you're classifying a data set, right? And you say if the first condition was true, then we are here. But like it's impure, like it's not 100% accuracy, right? And you say, oh, I still need to like narrow it down a bit, like add more conditions. So I'm just gonna say if the second condition was true, then it's this, and then if not, it's here. And then like here you get 100% accuracy in your data set, right? So these nodes that do not have an output, right? Like there is no more conditions applied on them. It's like pure nodes. These are called the pure nodes or the leaves, right? And then like the one at the very top, it's the leaf node, it's the root node, and these are the condition nodes, right? That you make decision based off of them. But actually, let's see how we can implement a decision tree on a sample data set. Because when you look at this, you say, okay, let's say I have a data set with like n features. How do I decide what feature I'm going to use? Because like these conditions are applied obviously on the features of your data set, right? So you have to make the decision, okay, like I have these many features, which feature do I use for my root? Which one do I use for here? Or like how deep is my tree? Or what are the conditions? Let's say like, for example, one of my feature is age, right? In a data set, for example, I'm saying, okay, let's say that I want to go with age as the root node. Then like, what's the criteria? What's the condition that I'm going to apply on that feature? We will be talking about all of these in a second. Okay, so here I have a data set. Let's say I have a data set of 7 people, 1, 2, 3, 4, 5, 6, 7 people, and we have different features. So the feature number 1 is if they smoke or not. The second feature if they do yoga or not, and the third one is their age, right? And then based on these 3 features, so I'm just saying that this is feature 1, this is feature 2, this is the third feature, and this is the output, right? So I want to use these 3 features to train a data set, to train a model, in this case, a decision tree model, to let me know based on these 3 features if the person is stressed or not. Okay, how do I make my decision? Like, how do I know if smoking or doing yoga or age goes to the root? We don't know that yet, right? So basically, all we need to do is to use the information theory to find the feature that gives us the best result, right? by the best result means like the feature that classifies it the best. So let's talk about smoking, right? If I go, for example, smoke here, right? If the person smokes, true. If they don't smoke, so false goes here. And let's compare these two, right? So I'm just looking at this feature and I want to see how well this feature maps to the result that I'm looking for. So, and let's say here I'm saying yes, no, yes, no. Okay. So this person smokes, right? So the condition is true. And then, but they're not stressed. So I'm just gonna go like they smoke, but they're not stressed. So no is one. Here again, they smoke, but they're not stressed. So that goes to two. And then here we go, they smoke, and then yes, they're stressed as well. So this is one. And then again, they smoke, but they're not stressed. So this goes to three. So we ended up with 1, 3. And if you do the same thing for like people who don't smoke, you will see that like this person doesn't smoke, this person doesn't smoke, this person doesn't smoke. And two of them are stressed. So I'm just going to go 2 under yes and 1 under no. And I'm saying, okay, so this is how well this feature classifies my output. But when you look at it, you're like, okay, but like I don't really understand anything. Like, give me a metric, right? So that I can compare that to something like, for example, the second feature or the third feature. I just want to know which feature is the best feature. To make it more numeric, so we can actually like measure it, they introduced something that is called the Gini impurity, right? To calculate the Gini impurity, it's Gini impurity, right? So it says 1 minus probability of yes squared minus probability of no squared, right? This is what we want to calculate. So like, as I said before, smoke, like that's a node. If it's true, it comes here. Here is a node, right? So I'm just going to go like this. And then this is also another node, right? Let me change this guy color. So it's better now. Now let's calculate the Gini impurity for this node in here. It's 1 minus, what's the probability of yes? We have 1 out of 4, right? Like we have 1 person in this class and 3 in this class. So we have 4, and it's like 1 over 4, which is 20.25, right? And squared minus, this is 3 over 4, which is 0.75 squared, right? And if you do the math, I think if I'm not mistaken, that's 0.375. And then you do the same thing in here. So you go 1 minus, what's the probability of yes? That's like on 2 over 3, which is like 6.6. That's squared minus 1 over 3, and that's squared, which is 0. I think 447, right? If you do the math. Okay, cool. So we have the impurity of this node, and then we have the impurity of this node, like the Gini impurity. And now what we need to do is to calculate the weighted average, because like we have 4 people in this class, and then we have 3 people in this class, right? Note that we want to calculate a metric or a factor, like a numerical number for this feature in here, smoke, right? Like if they smoke or not. So we have to like merge these two Gini impurity that we calculated and assign a single number to this node in here. Because the number of people in each category is different, then you want to do the weighted average. So I have 4 people in here, 3 in here. So what's the weight for this one? That would be 4 over 7 times what's the Gini impurity of this node? 375 plus this is 3 over 7, right? Because we have 3, and then that multiplied by 447. And this would equal to, if I'm not mistaken, 0.405. Okay, cool. This worked. Now we can do the same thing for the next one, right? Let's do some calculation for the next one as well. Now we are comparing the result for this feature with respect to the output, right? So we want to go here and say, if they do yoga, then yes or true. Let me just call that true. So this is true, and then this is false. And if they do yoga, and then I go yes, no, just like we did before, yes, no, you'll see that 3 goes here, like 3 people that do yoga, like for example here, right? So 1, 2, 3 people that do yoga are also stressed, and 1 is not, so that goes in here. And then if they don't do yoga, are they stressed? No, 0 goes here, and then 3 goes here, right? You can look at this. No, no, no. So 3 people do not do, and all 3 are not stressed. Well, this may not be the best example because apparently if you don't do yoga, you're not stressed. So you want to stop doing that. Anyway, back to the calculation. If you do the Gini, if you calculate the Gini impurity, just like based on what we did before, right? So this one, like the probability for this one, it's going to be 1 minus 3 over 4 squared minus 1 over 4 squared. And then for this one is going to be 1 minus, this is 0, right? 0 over 3 squared minus 3 over 3 squared, which like this one is 0 basically. And then you can do the calculation for this one, and then like do the weighted calculation, and then at the end you will get 0.214. So the first one that we calculated was 0.405, right? I'm just going to put it up here so I won't forget. 0.405. For the second feature is 0.214. And now I want to calculate the third one and see which is the better one. Note that, like, for example, if you look at this node, right, this one in here, if I do this and come here and say, like, look at this node, this is a pure node because the Gini impurity is 0, which means that like we have like 100% accuracy. If we get to this node in here, we for sure know that they are not stressed. As you can see, like nobody's stressed and some people are stressed. So like the accuracy of this node is like 100%. So that means that we want to choose nodes, right, or features or conditions that give us the lowest possible Gini impurity. So for the first one, it was 0.405. For the second one, it was 0.214. And now we have to calculate the third one. So far, the second feature seems to be the best. But okay, how do we calculate the Gini impurity for some numeric values, right? Because we don't really know how that works. Okay, let's see. I'm just gonna put the numbers that we calculated. 405 here, 0.214 in here, and now we want to do the age. Okay, to calculate the Gini impurity for this one, the first thing that you need to do is to sort this feature, right, from low to high. That's how I have it. 17, 22, 28 goes all the way to 93. And then you want to calculate the average between each 2 consecutive numbers that you have. For example, 17 and 22, right? So for this one, I'm just trying to write right in the middle. So that's like 19.5, right? So that's like 39. So yeah, 19.5. For the next one, that'd be 25, right? And then for the next one, 36.5, and then 46.5, if I'm not mistaken. Um, and then for this one, it's going to be 54. And then for the last one, you will get 76.5. I might have messed that up. I don't know, but hopefully these are correct values. Anyway, so let's say that we do the calculation, we have the average, right? And then what we need to do is to calculate the Gini impurity for each of these average values, right? I know this may sound like a lot of work, and yes, it is true because decision tree is a greedy algorithm, right? But like the math behind it is super simple. So let's say we have 19.5, right? So we go 19.5 here, and the condition is that like if age, for example, is less than 19.5, right? This is the condition. And if it's true, if it's false, and then we go yes, we go no, we go yes, we go no. So if age is less than 19.5, only one person falls into this category, and they're not stressed. So this is 1, this is 0, and if they're not, then you can calculate if they're stressed or not. So 1, 2, 3 people are not, and then 1, 2, 3 people are actually stressed, right? And then like you can calculate the Gini impurity for these numbers. And then you repeat the same for age less than 25 and then age less than 36. I calculated that, and the numbers that I got are like these. So this one goes to 429. This one goes to 343. And then like I calculated the average and stuff as well, right? So these are the final numbers that I have. This was 476. This one was 476. This one was 0.343, and then the last one was 0.429, right? So these are numbers that I calculated. Cool. So as I said before, we want to choose the lowest one. The lowest one seems to be this one in here, so age less than 25, and that's a tie with the second last one in here. They are the exact same values. It means that like you can choose either, right? So we can go with age less than 25 or age less than 54 for this condition. And so the lowest number that you get is 0.343. So I'm just going to put that in here, 0.343. This is a 4. And then when you compare these values, you see that, okay, this one, the second feature, like if they do yoga or not, has the lowest Gini impurity number, right? So this can be the root of your tree. So far, we can actually say that if they do yoga or not, right? Yes and no, or true or false, right? And then we have something. If they do not do yoga, so this person doesn't do yoga and it's not stressed, it's not. So if we go yes and no here, so we get 3 and 0. So it's like 100% accuracy in here, right? Which is good. So it means that we don't have to continue and go deeper in this branch of the tree. But when we get here, what will be calculated up here when we do yoga, it's like 3 and 1, right? So if I go here and say yes and no, it's 3 and 1. Now the question is that, okay, do I want to continue and going down like deeper in the tree to make it a pure node or not? This is like a decision that you have to make as a designer. The problem with that is that like if you keep going down and down and down, you had a really good tree with, all the leaf nodes being pure nodes, but sometimes it means that like you have overfitted your network because you're getting like 100% accuracy on each each leaf node, right? And sometimes it's not the best thing. But in this video, because like the purpose of this video is to teach you about, the decision trees, we want to keep going and we want to continue that, right? So let's go to the next slide and write down what we have so far. So we know that doing yoga goes to the root of the chi, and it's true, it's false here, and then we go yes, 0, no, 3, and then yes and no. Just want to remember the numbers, 3 and 1. 3 goes here, and then 1 goes here, right? Okay, cool. So now we want to focus on this branch. I'm just going to change the color and say that, okay, we want to focus on this branch in here. We show the people who actually do yoga. So I don't really care about this row anymore. I don't care about this row, right? And I don't care about this row. I only care about the 4 people, 1, 2, 3, 4 people that do yoga, because now I'm doing this branch. So doing yoga should be a true condition. And now I want to do the same thing again. Like I'm just going to go over these. I'm like, I have 4 people in here. Now I have 2 features. I have feature 1, and now A will be feature 2. Now I want to calculate the Gini impurity for feature 1 and feature 2, right? To see like which one is supposed to be the condition here, right? So I have 4 people in here, right? Now forget about this. I have 4 people. I want to say, do they smoke or not, right? I want to calculate the Gini impurity. True, false, right? So this person doesn't smoke and is not stressed. So I'm just going to go yes, no, yes, no. So this person does smoke but is not stressed. And this person doesn't smoke and is stressed. So it's 1, 1. And this person doesn't smoke and this person doesn't smoke, but they're both stressed. So 2 goes here, 0 goes here. You can repeat the same calculation for age, right? Now you have to do the calculation, like you have to calculate the average for 17 and 28, because these are the 2 adjacent rows, and then 28 and 45, 45 and 48, right? And then like you calculate the Gini impurities for all of them, and then compare with the Gini impurity that you calculate here. So in this case, it's 1 minus, what's the probability of yes? Like 0.5. This is 0.5 squared minus what's the probability of no? That's also 0.5. So 0.5 squared, which is 20.25, 0.25. So that's like 0.5. And this is 1 minus 2 over 2 squared minus 0 over 2 squared, which is 0. And then you calculate the weighted. So you have 2 people here, 2 people here. So you go 2 over 4 times 0.5 plus 2 over 4, because you have 2 people in this category, times 0, right? So it's like 0.25 for this condition in here, right? And then like you can basically do the same calculation for these guys in here. Like you have age 17, 28, 45, 48, and then you do the calculation and you figure out what's the Gini impurity is. And if it was less than 2 or 0.25, you go with that feature. And if it was higher than this, then you go with this feature. And basically all you need to do is to keep going, like continue this process recursively, right? Until you get to the all pure nodes. So all of your nodes are going to look like this, right? Like one of them is 0, the other one is an actual number. This one is 0, one of them is an actual number, right? You keep going until like you have that, but you may not actually get that in all data sets, right? And then as I said, sometimes you don't really want to do that because you're overfitting your data. But yeah, this is basically the theory behind it. Hopefully it wasn't too hard to understand and follow. Um, if you missed some parts, make sure that you go back and listen to what I said again. Make sure that you do the calculation again yourself, because watching me do the calculation and writing the GD impurity factor down, be like, hey, this is that. You may look at it and be like, oh, okay, I understand, but try to do it yourselves. It's very much different when you try on your own. Um, I think it's enough for today's video. In the next video, I will be showing you how we can actually implement that in Python from scratch. So please don't forget to subscribe to the channel so you won't miss the next video when I upload it. And thank you for watching me. And you guys have a good one. Take care. See you all in the next video. Bye bye.